Assalamualaikum. So we go for inverse matrices. Okay, first introduction. Let A and B be n times n matrices. Suppose that A times B equals to B times A equals to identity. This one. Then B, we call it as inverse of A. And is written as A power of -1. So then we write down again B as A inverse. So we will get A times inverse of A equals to A inverse times A equals to identity. Okay, we go for remark. A inverse inverse, so you inverse twice, is equal to A again. So this one is followed if A is invertible. So what is invertible? Non-singular. What is non-singular? Non-singular meaning determinant of A is not equals to 0. So why it is followed if A is non-singular? As you can see here, A inverse, you will use determinant of A. If determinant of A equals to 0, so 1 over 0 equals to infinity. So meaning you doesn't have A inverse. Okay. For B, there are many squares matrices that have no inverse. Okay, we go for properties of inverse matrix. So for A, transpose of A inverse, you can switch the transpose and inverse, this one. So you can inverse first and then transpose. For B, you can expand, but you have to do the nearest of inverse. Let's say here B is the nearest with inverse, so B inverse times A inverse. For this one, C is the nearest, so C B A. And for C, A inverse equals to 1 over determinant of A. Determinant of A inverse equal to 1 over determinant of A. And same as A here. And an inverse, you can switch inverse first and then power of n. Okay. Next. Inverse matrices, you have two methods to find it. First, it's adjoint and using formula. Second one is ERO. So remember back ERO. Okay, we go for first method, adjoint and formula. So for 2 times 2 matrix, you have A here, A, B, C, D. Here. Okay, A is non-singular. So remember back what is non-singular. And then the determinant, remember determinant AD minus BC. So here. And then we have to find adjoint. So adjoint, usually we just write down ADJ for adjoint. And how to write down the adjoint is we switch D with A, and then for CB we switch the positive negative. Okay, as you can see, AD switch the place, and CB switch the positive negative. So from left hand side it is positive, wait, where is it? Oh, here. Left hand side it is positive, so here it will become negative. Hence, formula for A inverse is 1 over determinant of A times adjoint A. So we substitute determinant of A as AD minus BC and adjoint A as D negative B negative C A. So that one for 2 times 2. Now we move to n times n matrix. So we go for A, B, n times n matrix. To find adjoint for A, we have to follow the steps. So what is the steps? For first one, we transpose A. Second one, we have to find cofactor for each entry. So remember back, cofactor. And then the cofactor is adjoint A. Okay, we go for example 1. Let's say A here, A, D, B, A, B, C, D, F, G, H, I. So we have to find adjoint A. So this one is A. First we write down back A. And then we transpose A. So ABC will become column DEF, DEF here, GHI, GHI. And then the next step, we have to find cofactor for each entries. So we have to put plus, minus, plus, minus, plus, tak perlulah, minus, plus, minus, plus. And then the minor for each entries. So this one is A11. So for A11, we just remove the row and column for A. So you will get EHFI, sorry, this one. For A12, we just remove column for D, column and row. So you will get BHCI. So here. So and each entries. So if 3 times 3, you have to get 9 cofactor. Okay. And then how to find adjoint? So this is the adjoint. Just read the cofactor. So AD minus BC. AD minus BC, AD minus BC, and so on. So that one is adjoint. Okay, finish for number 1. Number 2, this one, okay. So you have B, 1, 3, negative 2, 0, 1, 5, negative 2, negative 6, 7. So the first step is we transpose B. So 1, 3, negative 2, 0, 1, 5, negative 2, negative 6, 7. And then find the cofactor for each entries. So you will get here. And then just read the cofactor. AD minus BC. So you will get here this one with the negative and so on, and this is the answer. Okay, next, using formula, find the inverse. So for number 3, we go for terus inverse lah. So the first step, we find adjoint C. So first we write down C, and then we transpose. So as you can see, it is same 1 2 3 1 2 3 2 2 3 2 2 3 3 3 3 3 3 3, and then the cofactor, and then the cofactor, the last answer. Step number 2, we have to find the determinant C using Zero scheme. So remember back how to use Zero scheme. So 1 times 2 times 3 here, 2 3 3 here, plus 3 2 3 3 2 3, and then minus 3 2 3 minus 3 3 1 3 3 1 and 3 2 2 3 2 2. So you will get 3 as determinant of C. And last one, C inverse equals to 1 over determinant C times adjoint C. So determinant C is 3, substitute 3, and then adjoint. And then we can multiply 1 over 3 into the matrices. So this is the final answer. Okay, finish number 3.